Understand a very effective strategy to solve optimization questions based on quadratic applications. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider a real life situation. It is a question based on optimization. The question here is, a farmer needs 6 identical pens for the farm animals. He has 1800 meters of fencing. If the area enclosed is to be maximized, then what are the dimensions of each pen? You can always pause the video, answer the question, and then look into my suggestions. Well, in any word problem, it's better to visualize, make a sketch, define variables, write relations, and then solve. So we are going to use this strategy to find appropriate solution of this particular problem. So we are looking at few key things here, that a farmer has a fence and he needs to do 6 identical pens. And the fencing is 1800 meters of fencing. So that becomes the perimeter. And what do we need to do is to maximize the area of each pen, right? So we need to find dimensions for maximum area, right? So these are keywords. So, well, of course, these should be adjacent to each other, right? So they should have common boundaries, these fence. So let's sketch the fence and then we'll figure out how do we find the solution. So let us say that this is the total fenced area for pens in which we want to have 6 congruent triangles, exactly same, right? So let's say this is half of it and we are going to divide this into 1/3. Correct. So what we are given here is that this length is y and this is x. And we need to maximize the area of each pen. You get the idea. So that is the kind of layout. And from here, we should be in a position to get our equations. So how do we relate 1800 meters of fencing with x and y? This is the first thing which we need to consider. Well, how many y's are there? So if you look into y, so we got y, y, do you see that? So there are 1, 2, 3, 4, 5, 6, 7, 8 y's, right? Plus, how many x's are there? Let's use a different thing. For x, do you see that? These are all of length x. So we see we have 9 of these, correct? And this total is definitely equal to what? 1800 meters, which is the total fencing. So that relates x and y. Now, when we are talking about area, area definitely is equal to, there are 6 such cells, right? 6 times x into y. That is the area, correct? But this area is in 2 variables. We have to write them in single variable. So to write it in single variable, we could use one of our equations, which we just derived. And from this equation, we can write down what is y in terms of x, correct? And then get our equation. So we can rewrite this as 8y equals to 1800 minus 9x. Or we can say that y is equal to what? So we can say y is equal to, we are going to divide all this by 8. Correct? So dividing by 8, we get 1800 over 8 minus 9 over 8x. correct? Which is 18 goes 2 times, which is 16, and 20 means again 2 times, we got 40, 225, right? Minus 9 by 8x. Is that clear to you? Right? So we get an expression for the y in terms of x. Now once you get y in terms of x, you can substitute this value of y in the formula for area, and then you get the area, right? But the question really is not to maximize the whole area. The question is, if the area enclosed is to be maximized, then what are the dimensions of each pen? So since we are only looking into each pen, we need not do 6 times. You get the idea. Only 6y is enough. Perfect. So it is important to understand. So that is why we highlighted only one of these pens, right? So I hope the strategy is absolutely clear. Substitute the value of y in area equals to x times y, and then find the maximum, right? You can continue with this, but in case you want to learn directly from me, you can always send an email on the address given. Most of my students are doing extremely well. Some are right there on top of their class getting awards and scholarships, like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Okay. So let's continue with this on a fresh page and write down the function. So what we just discovered is that we have a relation where area is equals to x times y, and this area can be written as x times the y value. In terms of x was what? It was 225 minus 9 over 8x, right? So it is 225 minus 9 over 8x. So we have a function in x now which can be written as 225x minus 9 over 8x squared. Makes sense? So 225x minus 9 over 8x squared is actually the area of each pen, right? So we drawn this. I'm just redoing it for the convenience, right? So we had this, and the area is of this one each, right? Each pen, whose dimensions are x and y, correct? So that is what we are maximizing. This area is what we are maximizing. Do not multiply by 6. We just want one pen. Now, how do you find maximum from here? Well, you know this is a parabola which is going downwards, right? So effectively, it is a parabola which you could sketch kind of like this. Correct? Now, if that is the parabola, the maximum occurs right in the center. So the idea is to find these points. One of them is 0. What is the other point? Well, you could factor and then figure it out, right? So for that, I'm going to write A as, let's take x common, right? So if I take x common, I get 225 minus 9 over 8x. Correct? So these two are the factors. 0 we get from the x. The other 0, we have to equate this, right? So the other 0, let's calculate. So that is at 9.8x should be equal to 225, right? So if 9.8x is same as 225, we get a 0. So that is how we are going to find the value of x, which is 225 times 8 over 9. Is that clear to you? So let's multiply 225 times 8 divided by 9. What do you get? Well, very good number. So can you just do it? Dividing by 9, you get 200, right? So this value is indeed 200. So we have this value as 200. Do you see that? The other x-intercept. So between 0 and 200, what is the center value? Well, definitely it is 100. So we have the axis, which we call as axis, at x equals to 0 plus 200 divided by 2, which is indeed 100. So at 100, we get the value of x. So one of the dimensions of this particular thing is 100, right? Do you see that? The other one is y. And you know the y is 225 minus 9 over 8x. Perfect. So let's rewrite. So we get that y is 225 minus 9 over 8x. And we already know that x is equal to 100 for the maximum. So y is how much? So y will be 225 minus 9 over 8 times 100, right? Let's calculate. So we get 225 minus 900 divided by 8, and that gives you a value which is 112.5, right? So that becomes the value of y. So we have calculated that to maximize the area of each pen, what is really required is x should be how much? 100. And y should be how much? 112.5. Do you see that? So we have these dimensions right there. We have 11, 2.5, 112.5, and this side here is 100. Do you see that? So we have our answers for dimensions for maximum area of a pen, one pen, right, is 100 meters by 112.5 meters. You get the idea. So that is how we are going to answer this particular question. So I hope the steps are absolutely clear. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. And in case you want to learn directly from me, send an email. Right. Thanks for your time and all the best.